Welcome back to another explainer. Man, I am absolutely thrilled to take you on this mind-bending journey today. We're diving straight into the bleeding edge of theoretical physics, looking at stuff that literally challenges the bedrock of how we perceive, well, everything around us. If you think you've got a solid handle on how the universe works, you might want to buckle up, because we're about to flip that perspective completely upside down.
So consider this. What if time, space, and reality itself are just an illusion created by information? I know, it sounds straight out of a sci-fi novel, right? But this is exactly what the latest breakthroughs in quantum gravity and relational quantum mechanics are pointing to. We instinctively feel like space is just this empty box we live in, time is a ticking clock on the wall, and facts are just absolute facts. But we're looking at two groundbreaking papers today, one by Alain and Carlo Rovelli, and another by Arash Sagi. And let me tell you, they make a genuinely compelling case that our fundamental assumptions about our own existence might be completely backward.
Okay, let's dive into this. Here's our roadmap for the explainer. First, the crisis of reality, then the end of absolute truth. Time is an emergent illusion, space built from entanglement, what actually makes an observer, and finally, a unified universe of information. We've got a ton of fascinating ground to cover, so let's get right into it.
Section 1, the crisis of reality. We're looking at the cracks in classical physics.
Now, you probably already know that for a century, physics has been totally haunted by these deep, unresolved contradictions. We've got general relativity's smooth, continuous spacetime on one hand, and the bizarre, discrete, jumping rules of quantum mechanics on the other. Our comfortable classical worldview assumes absolute time, objective space, and observer-independent facts. Basically, if a tree falls in the woods, it makes a sound, period. But the quantum view, it totally shatters this. Down at the quantum level, there is no global time, systems are holistically connected across vast distances, and crucially, facts are contextual. They depend entirely on the observer. Trying to match these two views together mathematically has honestly led to a total crisis in the field. And to prove this isn't just navel-gazing philosophy, let's walk through the famous Wigner's friend thought experiment, which recently culminated in the Frauchiger-Renner paradox. Okay, step 1. A friend inside a perfectly isolated lab measures a quantum system. Step 2, they record a definite result. Let's say the particle is spin up. For the friend in the lab, that is an absolute, undeniable fact. But then, step 3, Wigner is standing outside the lab. Because the lab is completely isolated, standard quantum mechanics says Wigner has to model the entire lab, friend included, as being in a superposition of states. Which brings us to step 4, the paradox. Whose reality is actually true? Because if we assume a single observer-independent reality exists out there, the math just breaks. It leads to fatal, unavoidable contradictions. Moving on to Section 2, the end of absolute truth, where we'll explore relational quantum dynamics, or RQD. Now, what's really interesting here is how theoretical physicist Arash Sagi proposes solving these mathematical paradoxes. And his solution is pretty shocking. There is no God's eye view of the universe. Zaki puts it like this: there is no single observer-independent reality. Facts only become definite within specific observational contexts. Think about what that actually means. Reality is entirely indexical. A fact isn't just some universal truth floating out in the void. A fact is only true relative to a specific observer. So Wigner's reality outside the lab and the friend's reality inside the lab, they are both perfectly valid, but they're completely unique to their own frames of reference right up until they actually interact. So reality, then, is fundamentally an informational relationship, not just a bucket of isolated objects. You kind of have to think of the universe less like a giant global theater stage populated with pre-existing props, and more like a massive network of localized conversations. Things only take on definite properties when they are actively exchanging information with something else. It's the interactions, the relationships themselves, that form the actual bedrock of existence. Section 3, time as an emergent illusion, looking at the thermal time hypothesis. Okay, so if reality is just relative information, what the heck is a clock actually measuring? Why do we feel time passing at all? Let's unpack this with the thermal time hypothesis. This is the idea that the physical flow of time is not a universal property of mechanics, but rather an emergent illusion, and it's determined entirely by the thermodynamical state of a system. I know, that's a mouthful, but it means time isn't this ticking background parameter of the universe. Time is literally born from heat, entropy, and statistical ignorance. It's wild to think about, but it's the ultimate physical reason why time flies when you're having fun and grinds to a halt during a boring meeting. Well, statistically speaking anyway. And to give this some serious, massive credibility, we turn to the foundational paper by Alain and Carlo Rovelli. They mathematically deduced that, and I quote, The physical time is the modular flow of the thermal state. See, in the quest for quantum gravity, equations constantly suggest the universe is entirely timeless, just a static, frozen block. Cones and Rovelli totally solved this timelessness problem by proving that time is simply what we experience when we interact with the thermodynamic blur of a highly complex system.
This is where the physics gets incredibly exciting. Basically, Cones and Rovelli used a heavy-duty piece of math called the Tomita-Takesaki theorem to prove that any thermal state automatically generates a sequence of changes. It generates a flow. And the brilliant part? When you zoom out to our normal, macroscopic, everyday perspective, the non-relativistic limit, this generated flow perfectly matches the standard time we experience on our wall clocks. It's seamless. It even naturally explains deeply complex phenomena like the Unruh temperature, which is where an accelerating observer actually detects heat in an empty vacuum. It all points to one unbelievable conclusion. Time and heat are fundamentally the exact same thing.
Moving right along to Section 4, Space Built from Entanglement. Let's dig into the geometry of information. So naturally, the next question is, if time is just an illusion generated by thermodynamics, how do we explain the physical space around us? Well, just like time, space-time is not a fundamental stage. It is a web woven entirely by quantum correlations. In this new physics paradigm, distance is no longer an absolute measure of an empty void. Instead, distance is literally just a measure of how much information two systems are sharing. And this brilliantly illustrates the concept. Think of it like this. High entanglement means two systems are sharing a massive amount of information. So for all intents and localized purposes, they effectively sit close together in space. Low entanglement means they share very little information, so they act physically far apart. And if you were to completely destroy the entanglement between two regions, the very connectivity of space-time itself would tear apart. Classical space dynamically emerges as a coarse-grained, zoomed-out approximation of these underlying invisible quantum links. It's like looking at a tapestry from far away and seeing a smooth picture, rather than the millions of individual threads.
All right, Section 5, what makes an observer? We're going to look at integrated information theory.
This begs a huge question, right? If everything is just a web of relative information, what actually defines who or what is looking? Notice how for a hypothetical observer, the information contained in its isolated parts is just this tiny little sliver. But that massive chunk, that represents the surplus integrated information, the holistic structure. See, an observer isn't defined by having a human brain or a conscious soul. An observer is strictly just a physical system that generates significantly more information as a whole, integrated unit, than the mere sum of its individual isolated parts. To really see this in action, just compare a single electron to a human brain, or even a supercomputer. An electron has zero or near zero integrated information. Because of that, it has no unified perspective. It absolutely does not observe the universe. But a human brain, or a highly complex mechanical detector in a lab, it has an extremely high level of integrated information. That dense, intricate web of internal correlation is exactly what gives it a definite, unified classical perspective. There is no magical hard dividing line between the bizarre quantum world and the normal classical world we live in. It's literally just a sliding scale of informational complexity. Which brings us to our final section, Section 6, a universe of information. Let's put this whole paradigm together. Let's move to how this builds into one grand unified worldview using Zaghi's 5 pillars of reality. Number 1, states are entirely contextual to the observer. Number 2, time is a modular emergent illusion born from heat. Number 3, the very geometry of space is built out of entanglement. Number 4, observers are simply systems with highly integrated information. But wait, there is a 5th pillar we absolutely need to make this whole shebang actually work: quantum decoherence. Decoherence is the final, absolutely crucial ingredient here. It's the process by which the surrounding environment incessantly measures a system, suppressing all that weird quantum interference and leaving behind stable, classical records. Think about it. If reality is relative to the observer, why do you and I both agree that the sky is blue? It's because we are both constantly, inescapably interacting with the exact same massive environment. Decoherence effectively forces our relative perspectives to align with each other. It perfectly answers why we agree on shared facts without needing to invent some mystical wave function collapse to explain it. When you stack all these pillars together, the ultimate takeaway is just profound. Reality is not made of stuff. There are no tiny, solid billiard balls making up the universe.
It is a pure network of information experiencing itself. The rigid, ticking, geometric universe we all thought we lived in, it's actually a dynamic, living web of correlations.
We have completely dismantled the illusion of classical reality today. But I want to leave you with one final, incredibly provocative thought. If a system only becomes real and only takes on definite properties when it interacts with an observer, and if reality itself is just an endless interconnected web of relative information, who or what is observing you right now to make you real? Think about that for a minute. Thanks so much for joining me on this explainer, and as always, keep questioning everything.